So in this video, we're going to solve this problem where we're told to calculate the equilibrium constant of the following reaction at 298 using the information provided. So again, what are we trying to find? We're trying to find the equilibrium constant. And the information that we're given is these Gibbs free energies of formation. And this really comes from Appendix G of your textbook. So how are we going to go about this? Well, we need an equation that's going to relate the equilibrium constant to our delta G under standard conditions. And so we can say the equation we want to use is going to be delta G naught, which is equal to negative RT ln of K. So this is the equation we want to use to solve for K. So first, we need to find delta G naught of our reaction. And remember, to do that, we're going to do delta G naught of our reaction is going to be equal to the sum of all of our products, delta G, minus the sum of all our reactants, delta G. And so delta G naught of our reaction is going to be our products. We have to pay attention here. There's two NO2s, so 2 times 51.3 kilojoules per mole, minus our reactants, which is just going to be 99.8. There's only one of them. And so we can plug that into our calculator, and we're going to get delta G of our reactions ends up being 2.8 kilojoules per mole. So once we have delta G, we can now come into our delta G expression, right? And we're solving for K. So I'm going to rearrange this expression. So I'm going to put it in terms of natural log of K. So natural log of K is going to be equal to delta G naught divided by negative RT. And so we can start substituting in, watching units. Natural log of K is equal to, and be careful, R is in joules per mole, and this is in kilojoules per mole. So I'm going to switch this and say this is equal to positive 2,800 joules per mole divided by negative times 8.314 joules per mole times Kelvin times, and we're told in the problem we're looking at 298, so that's our temperature, 298 Kelvin. And so our natural log of K, put that into your calculator, you should get negative 1.13. Now we need to find K, and in order to find K, if you haven't done this before or don't remember how to do this, if we want to solve for K and get rid of that natural log, what you want to do is on your calculator, K is going to be equal to e to the negative 1.13. So this e function, e raised to the exponent, is really the inverse natural log, if you will. So you need to find the e exponent button on your calculator, and to take e raised to what we have here. And when we do this, we should end up with K is equal to 0.32. And that's our equilibrium constant for this system.